The last type of function that we learned about this year was exponential functions, and the growth and decay function for exponentials is y equals a times the quantity 1 plus r to the power of x, or to the power of t, and we called that our ART formula. We also talked about standard form, which was y equals ab to the power of x, and we talked about compound interest, and we said compound interest was p times 1 plus r over n to the power of nt. These two are given to you on your formula sheet, so you do not need to memorize those. You do have to memorize the ART formula, so we are going to go through an example of that right now. So number 25 says, suppose that as a New Year's resolution, you decided to save your money in the following way. Before the start of the year, you had 25 cents in a piggy bank. Each day, you would double the money in your piggy bank. So using this, you have to determine, are we using y equals ab to the x, y equals a times 1 plus or minus r to the power of t, or compound interest? Your key word for this one is going to be double, and double is a growth factor, and your growth factor would be 2. So we are going to use y equals ab to the power of x, where a is your starting value. We said we started with 25 cents. B is your growth factor, which we said was 2 to the power of x, or dependent on time. Part B asks how much money would you have after 5 days. So you're going to use your equation, and where you have an x, you're going to plug in a 5. So you'd have y equals 0.25 times 2 to the power of 5, and your calculator can do that for you. So you have 0.25 times 2 to the power of 5, and you get 8. You would have $8 after 5 days if you were doubling your money starting with a quarter. 26 is very similar. It says the state basketball tournament starts out with 128 teams. After each round, half of the teams are eliminated. This is also a y equals ab to the power of x example, where b is going to be half. So our starting value was 128, so that's going to be my a. My b is going to be 1/2. So we have y equals 128, my starting value, times 1/2, or you could put 0.5 to the power of x. They're asking me how many rounds would it take for only 4 teams to be left. So now y is going to be 4. So I want to know 4 equals 128 times 1/2 to the power of x. And luckily, solving for x in an exponential function was not an algebra standard. So we're just going to start plugging and chugging in numbers. So we're going to do 128 times alpha y equals enter 1 over 2 to the power of 1. And I get 64. So after 1 round, there would be 64 teams left. Let's see how many would be left after 2 rounds. So I'm just going to go highlight it, enter it, and change my 1 to a 2. There's going to be 32 teams left after 2 rounds. 3 rounds. 16. We're getting closer. 4 rounds. 8. 5 rounds. 4 teams. That's exactly what they were asking me. After how many rounds would there be 4 teams left? So you have to go through and see how many teams are left after each round. Now you can tell that this is going down by 1/2. So it's dividing by 2 every time. You could have just done divided by 2, divided by 2, divided by 2 until you got to 4. Either way works. That was just one way to do it. Now we're going to talk about exponential graphs. So there were 2 types of exponential graphs we looked at. We looked at growth and we looked at decay. Remember, you read it like a book. So write it from left to right. This one is going up. This one is going down. Because you have a double or a positive growth factor, you know that this is going to be going up. Because it is going, for this example, it's going down every time, or it's decreasing by 1/2, you know that it is going to be decay. You could also look at your starting values. You can't see the y-intercept, but you know the y-intercept for this graph would be 128 because that's how many teams you started with. Your y-intercept is always your starting value. Always, always. So your y-intercept for this one would be 0.25 because you started with 25 cents in this first example. The last thing you have to do today, and that will be graded, is the back page of this packet. So the back page of this packet goes through a linear example, a quadratic example, and an exponential example. I need you to do all three of these problems. You are going to solve the problem, and you're going to tell me if it's linear or exponential, and how did you know. If you don't do this back page, you're going to get a 0 for this assignment. It is critical that you practice what you just learned in these videos. So now that you're done watching the videos, do these three problems, turn this packet in, and be ready to take a quiz here in a few minutes.